Hello everyone. So far we are done with the theory part till speed and velocity. So today we'll do the remaining in-text questions. So first in-text question, distinguish between speed and velocity. So as we know, speed and velocity are somewhat related, somewhat not related. Speed is your distance upon time, whereas velocity is your displacement upon time. So your answer will be speed is the rate of change of distance, whereas the velocity is rate of change of displacement. Next, under what condition the magnitude of average velocity is equal to average speed? Now, average velocity and average speed will be same only if the object is moving along a straight line path. Because if the object is moving along a straight line path, then distance and displacement will be same, and so is the speed and velocity. So your answer will be speed and velocity for an object will be same if object is moving along a straight line path. Next, what does odometer of an automobile measures? Odometer is used to measure the distance covered by your vehicle. So odometer gives us the reading how much distance you have covered or how much distance your car has covered since it has been come into use. The next, what does the path of an object looks like when it is uniform motion? So just recall the definition for uniform motion. If an object covers equal distance in equal interval of time, that is said to be uniform motion. So path will be a straight line for a uniform motion. Next is a numerical. During an experiment, a signal from a spaceship reached the ground in 5 minutes. What was the distance of the spaceship from the ground station? The signal travels at the speed of light, that is 3 × 10⁸ meters per second. So in this question, you have been provided the speed, you have been provided the time taken by the signal. You are supposed to calculate the distance. So you write it as time is 5 minutes. 5 minutes converted into seconds will be 5 into 60, which gives us 300 seconds. The next speed is 3 into 10⁸ meters per second, and you are supposed to calculate the distance. So as we know, distance is your speed into time. So this will be 3 into 10⁸ multiplied by 300, which gives us the answer 9 into 10⁻10 meters. This 3 with 3 gives us 9. This is 8. Here we have 2 more zeros, so 10⁻10. So displacement will be 9 into 10⁻10 meters for the spaceship. Now the next question is, when will you say a body is in uniform acceleration and non-uniform acceleration? Now as we know, acceleration is rate of change of velocity. So uniform acceleration means the velocity is changing with equal amount in equal interval of time. For example, we can say an object falling freely under the effect of gravity. So here acceleration will remain constant, that is 9.8 meters per second square. Whereas for your non-uniform acceleration, it means the body is covering non-equal values of velocity for equal interval of time. Let's say for example, a car on a highway going through some traffic, so its velocity will increase or decrease with some random values. So this will be an example for non-uniform acceleration, whereas a free fall will be example for uniform accelerated motion. The next question is, a bus decreases speed from 80 km per hour to 60 km per hour in 5 seconds. You are supposed to find the acceleration. So in this question, we have been provided the initial velocity, we have provided the final velocity, and we have been also provided the time in which that change has been brought up. And you are supposed to calculate the acceleration. Now as we know, acceleration is rate of change of velocity. So its formula will be v minus u upon t. So here u is 80 km per hour. Now, as we know that the SI unit is meter per second. So this will be converted to meter per second by the factor of 5 by 18. So 80 multiplied by 5 by 18, and the answer comes out to be how much? 22.22 meter per second. Whereas final velocity is been given as 60 km per hour. So again converting into meter per second, 60 into 5 by 18, this will give us the value 16.66 meter per second. Now as you can see, we have initial velocity now, we have final velocity, and time has already been given to us as 5 seconds. So applying the formula of acceleration, A equal to v by u upon t. V final velocity, that is 16.66. u initial velocity 22.22 divided by time, that is 5. Okay, so we were here, we have placed the values of v and u, and we got the value as minus 1.1 meter per second square. Now minus value represent here that velocity is decreasing with time, and 1.1 represents that 1.1 meter per second velocity is decreasing per second. Okay, now the next question is, a train starting from a railway station and moving with a uniform acceleration attains a speed of 40 km per hour in 10 minutes, and you are supposed to find the acceleration. Now in this question it has been mentioned that a train has started from rest. So what does that mean? It means that initially train is at rest, means u is 0. Now next, final velocity is 40. So v is 40, but it is 40 km per hour. So as you remember, whenever we have speed in kilometer per hour, we have to convert it into meter per second. So it will be 40 multiplied by 5 by 18. 40 multiplied by 5 by 18 will give us the value of 11.11 meter per second. So here, train started from rest 0, attains velocity 40, that is 11.11 meter per second, and the time taken by train for the change is 10 minutes. So again, it's in minutes, so it has to be converted into seconds. So 10 into 16 gives us 600 seconds. So now we have u initial velocity, we have v final velocity, we have time 600 seconds. So acceleration is what? Change in velocity upon time. So change is 11.11 minus 0 divided by 600. So this gives us the value of 1.85 into 10 raised minus 2 meter per second square. So our train is accelerating at the rate of 0.001 meter per second square. Alright, now the next question. What is the nature of distance time graph for uniform and non-uniform motion? The distance time graph for uniform and non-uniform, the difference is about how the curve is being drawn. See here, when the object is in uniform motion, then the curve will be a straight line. So this is your distance, this is your time, and this straight line or straight curve represents uniform motion. Whereas for non-uniform motion, it's a curve bent with certain angles, maybe inward or it can be outward as well. Either way, the motion is said to be non-uniform, and here the motion is uniform. Okay, now the next question. Next question is, what can you say about the motion of an object whose distance time graph is a straight line parallel to time axis? Now this is a quite good question. Here you need a little in-depth understanding what does distance time graph actually represents at every point. The question says that line is parallel to time axis. Now if you see the graph closely, you can observe that for every instant of time, the distance is same. No matter what time we are, it is representing exactly same as, let's say it is x. So what does this mean? This means our object is at rest. Why rest? Because distance is not changing, means the object has to be stationary. Okay, now next question. The question is, what can you say about the motion of an object if speed time graph is a straight line parallel to time axis? Now this time, speed time graph line is parallel to time axis. Here we have distance time graph parallel to time axis. Now we're gonna have speed time graph and line is parallel to time axis. Same. So this is your gain time, this is your speed S or V. Now according to the question, the line is parallel to time axis. Now what does this imply? This implies that the object is having exactly same speed for every instant of time. Let's say P or V. So this implies object is in uniform motion. And even if you write uniform, non-accelerated or unaccelerated motion, will remain the same answer. Okay, so if the line is parallel time axis and the graph is speed time graph, then the object will be in uniform motion. If it is distance time graph, then parallel line will represent your stationary position. Okay, now next question. What is the quantity which is measured by the area occupied below velocity time graph? So area under VT graphs gives us displacement. How? See, like this is your time, this is your velocity, and the object, for the sake of example, is in uniform motion. Let's say moving the speed of 20 meter per second. Alright, and it has moved, let's say for time 20 seconds. So here, as per our basic rule, your distance is what? Velocity into time. So this will be 20 into 20, which gives us 400 meters. But instead of using the traditional formula, if I want to calculate the area of this VT region, then this is the shape of a rectangle whose side is 20, whose length is 20. We call it a square as well. Area of rectangle is L into B. So 20 into 20 will give us 400. So we can say that area under VT graph gives us displacement.